Okay, we are doing a starter problem, which is actually pretty challenging. So, how many of you are confident you had the right answer? But how many of you had an answer that was different than the person next to you? Okay, 1, 2, 3, 4, 5, 6. Okay, so I guess most people seem like they think they have it, but let's talk it through. So first step was we had to draw these triangles. This line right here didn't exist. And we had to draw it. Why? Because we needed a right triangle where we knew a side in the right triangle. That was the blue one. And then hopefully you knew enough to write a trig equation for that. And that's going to be, if I want this side here, I'm going to call it the squiggly side. If I want the squiggly side, I want opposite and hypotenuse. So you go sine 30 is equal to opposite. I don't know it. I'm going to put x over hypotenuse, which I knew. This is a weird place for the hypotenuse, but that's what it is. And it's 1.43. And then basically, it comes out to half of 1.43 because sine of 30 is a half. I know that just from memorizing it, and you should memorize it too. It's going to come up a ton. Nice to know that one. Otherwise, you can type into the calculator sine 30 equals 0.5. And then I have 1.43. I'm going to multiply by 1.43 on both sides. So somebody tell me, what did x come out to be for that? 0.7115. Raise your hand if you got the same thing for that. Okay, good. That was the first step. Next step. If this is 0.715, then now I know a side and an angle of this one. The angle isn't so instantly apparent, but as soon as you realize that's 60, and together this and this and this have to add up to 180, then I really already have 105. That leaves, would you agree with 75 degrees there? All right, so then I have a 75-degree angle there, and I'm going to use the squiggly side that I know as one of my sides, and that is, let me think, from the right angles perspective or the 75's perspective, that's the adjacent, and what I want is the hypotenuse. So I'm going to go adjacent hypotenuse is cosine. Cosine is 75. Now, if you use the wrong function, that could have messed you up. Cosine is 75. Adjacent over hypotenuse. The adjacent is that 0.715. Over the hypotenuse, I don't know. I'm going to call it h for hypotenuse. Although it's a small h, at least instead of a big H. Probably be better if I used a different letter, but I'm going to stick with it now. And then I go cosine of 75 on my calculator. And then I would multiply both sides by h. And in the all said and done, it's 0.715 divided by cosine of 75. How long was that hypotenuse thingy right here? Anybody verify 2.76-ish? All right. So if that's about 2.76, then I once again have a right triangle with a side and an angle. And this time I want opposite and hypotenuse. And so I do sine. The final one was sine of 45 is equal to opposite, which is h. No, wait. Yeah. Big H over hypotenuse, which is 2.76. So then when it was all totally done, what did you get? 1.95? All right, cool. Okay, that's a tough kind of question, but it's about the level we'd expect you to be able to handle because it's tricky. Don't expect the easy ones. Maybe a couple easy ones. All right, so back to the stuff for today. I really need to remind you about the 30, 60, 90. So for right now, would you please scribble out this and this? And just tell me, what are those side ratios? Like 1, 3, and square root of 4? No, that's not it. What are they? Write them on the triangles in the right spots. Like if you think this is 1, 2, and square root of 3, you're sadly mistaken. It's not. But it's something like that. So please write those on for both triangles. And let's just see if you know. Side ratios. All right. Now, compare them with the kid next to you. Okay. So 1, square root of 2. Raise your hand if you had that one right. Good. The other one, 1, 2. I like to do it in this order because the smallest side and the biggest side are twice as big as each other. Or the ratio is 2 to 1 or 1 to 2, depending which way you do it. And square root of 3. Raise your hand if you had those right. Okay, good. It's so easy to get them reversed a little bit and put the square root on the, because this square root is on the hypotenuse, a lot of people put the square root of 3 right there, and it's not right. Okay, good. Now that we have those, how can we use that to figure out, without a calculator, if this side is actually 25? Do you get that all the sides are 25 times bigger than our original ratio? So if this side is not 2, it's what? It's 50, 25 times bigger. And this one is what? 25 square roots of 3. All right, now what if you didn't want to do it that way? Let me show you another way. If you know the ratios are 1, 2, and square root of 3, I like to draw a little helper triangle, I call it. 1, 2, square root of 3 off to the side. And then I say to myself, okay, self, what trig equation could I write? Which side do you want? Well, let's say I want this one. I'd say cosine of 60 is equal to adjacent over hypotenuse 25 over x. And then I could solve for x. You get how to set that up? And then you might say, but you said I can't have a calculator, so how am I supposed to get cosine of 60? From this. The cosine of 60, cosine is adjacent over hypotenuse. It's 1 over root 3. Did I do it wrong? Cosine adjacent, yeah, thank you. Adjacent over hypotenuse. Cosine is 1 over 2. So the cosine of 60 is 1/2. So it's 1/2 equals 25 over x. Then I multiply both sides by x. Divide both sides by 1/2, where in other words, multiply by 2, and I still get x equals 50. All right, I know the other way is way quicker. But on this problem right here, I think you'd like that helper triangle way better. In other words, I think on this type of question, you're going to be better off with the helper triangle. All right, so I'd show you both. You pick. Okay, so you feel comfortable with solving those kinds of questions? All right, let's move on. The next kind is bearings versus true bearings. There's 2 ways to describe, actually there's many, but there's 2 main ways to describe where this arrow is right here. All right, there is 2 ways to say that spot, because in one system of doing degrees like this, you only have a number. They just say, I want you to set a course for 270 degrees. It's simpler. It's just one number. There's no east, north, south. Where the heck would 270 be? Well, you start here, and this would be 180. That'd be 270. Do you get how that's the direction they were talking about? So therefore, when they say set a course at 270 degrees, what direction are they sending you? West. All right? So this spot, the way to do it with that system is this is past 270. How far past 270 is it? Well, it depends. What they were giving the 70 was this way. So that means this must be 20. So under that first system of measurement, you would not say 70 at all. You'd say 270 plus another 20 that's 290. You get that arrow right there could be called at 290 degrees. Because you start here and you just keep going around, count 90, 180, 270, 20 more, 290. 290 degrees. That make sense? That's one system, one way to do it. There's another way to do it. That way. If I say north, 70 degrees west, what that means is start at north. It's kind of like this. and then swing 70 degrees to the west. Do you get how I could say this is north and then swing 70 degrees west? It feels weird. And then there's a third way, but I'm not even telling you that. But it's kind of complicated enough to have two systems. All right, I'd like you to see if you know where north 20 degrees east would be. Where should I put this arrow now? So what I want you to do is draw in an arrow at north 20 degrees east and see if you're in the right spot when I show you. North 20 degrees east. So I like to think of this as start at north and then go 20 degrees east of that. Did you have it there? Raise your hand if you had that right. Okay, good. So it's not impossible to do that. And then the true bearing for that would be what? 20, because you start here always at 0 degrees and you go that way and you just keep counting and that's 20. So this would be 20 degrees. All right, try the next one. Put an arrow in for me. Where should I swing this arrow to go west 45 south? Well, here's west. 45 degrees south of there. Raise your hand if you were pointing in the right direction. Good. Now, if you had used that other system, the true bearing for it would have been what? Don't say it. Write it. And then I want you to zoom in on it and compare it with the kid next to you and see if you guys agree with each other. Give you a hint. It's over 200. What'd you get? Who had 225? Excellent. Because it's 180 plus another how much? 45, 180 plus the 45, 225. All right, good. I think you're getting it. That's the two systems for degrees. Bearings versus true bearings. Compass bearings versus true bearings. And scarily, there's another way to do it on compass bearings. But again, I'm not even going to tell you I get 3 ways, and I don't think you're going to remember any of them. So, all right, then the last topic is angle of elevation versus angle of depression. All right, angle of elevation. If you elevate, do you know that kind of like, it sounds like elevator. It's usually you think of going up, right? Okay, so the angle of elevation is from normal. Look at, this is considered normal, looking straight across. Angle of elevation is how much you go up from normal. Does that make sense? So that's the angle of elevation. So if they say the angle of elevation to the building was 20 degrees, that's 20 degrees. But what if you had drawn your triangle this way? Isn't that also a triangle you could make? And do you get if you had drawn it that way and you'd thought, oh, I'll put my angle of elevation in here at 20 degrees. You'd be totally wrong. So there's always 2 angles involved, and you got to get the right one. The angle of elevation, if this is 20, which is the right way to do it, then what's this angle actually? 70, because they have to add up to 90. Make sense? So if you draw the red triangle, you'd have to use 70 for that. All right, same idea. I want to see if I can catch people on this. I know I'm gonna. There's a person standing on top of a building. And I'd like you to draw me a triangle for this situation and label all 3 angles in your right triangle. He looks down and sees a bug on the ground, the VW bug. All right, I don't know how to make it cute like they do in real life. VW. It's a diesel, and it has very pure emissions. Very clean burning diesel. Sorry, hitting the Germans pretty hard there. Anyway, you remember that diesel crisis? Yeah, they were saying their diesels were like very clean burning, and turns out they were cheating, and they admitted it, and their VW stock has gone down huge because they're going to have to pay like 90 billion in fines for selling vehicles that they were saying were super clean burning, and they weren't at all. They were like 90 times as much as emissions as they were saying they had. So anyway, back to, he sees a VW, and the angle of depression, do you get that that's going to be different than elevation? The angle of depression to the VW is 40 degrees. Draw me the right triangle involved and label all three angles. I know a lot of people are going to do it wrong. Be careful. The angle of depression is 40 degrees. Yes, sir. VW thing, I'll pause for a second. Okay, I'm thinking a lot of you probably did what I would have done. Make your triangle, and then go angle of depression, he said 40. And that obviously is a down angle, so I'm going to go 40 here. And then here's 90. And I'm going to split through 50. That is the wrong answer. If the angle of depression is 40, that means from normal, the angle going down from normal is 40. Therefore, what's that angle really? 50. And this angle would be 40. See how easy that mistake would be? Don't make that mistake. And then if you don't make that mistake, the problems are really easy. They're really not hard at all. Because now I got a triangle, and they'll give you one of the sides. Like they might say the height of the building was 30 meters. So now I got a side, I got an angle, I can find any side you want. So then they might say, if he was Spider-Man and he was going to shoot his web from the roof down to the VW, that's the hypotenuse, obviously, then what would it be? So would you please find that for me? What's the hypotenuse in this situation? We'll see if you know how to set up a trig equation. Do it now on the iPad. You need to actually write. I'm thinking is not a good enough excuse. Engage finger. Right. 30 is in, it's in meters. And I want to know the height. Sorry, the hypotenuse, sorry. The height's already known, it's 30. What equation did you use, Miss B? Sine of 40, and that would imply opposite over hypotenuse. And what's the opposite? 30 over the hypotenuse, h. Excellent. I erased my little helper things there, and there you have it. And now if you can just type in sine 40 on your calculator and then solve for h, it'll be a piece of cake. So what did you get for sine 40? No. What did you get for sine 40?
Well, I got the answer.
Cool. What'd you try typing in sine 40 for me then?
Okay. Sine of 40 is equal to 0.643.
Excellent. That's what I would expect to see on your paper. That's why I thought maybe you'd have it. And okay, that is another option. Thank you. And I'm going to multiply now by h on both sides. 0.643h equals 30. And then I divide by 0.643 on both sides. H equals whatever 30 divided by 0.643 is. What did you get? Can anybody verify that one? All right, good. Well, rounding could be off depending on what numbers you used. But within rounding error, raise your hand if you had 46.7-ish. Okay, good. So that's angle of elevation and angle of depression. So now let's start your homework together. Everybody get to, not the lost puppy problem. We got to get to the homework. There it is. Required, day 1. Okay. Now, sometimes people get obsessed with this exactly where on the swing set. The swing set is just like a dot. Okay, so this is a place. We're not going to worry about exactly how high the person's head was on the swing set when they saw the top of the building. That's a dot. And the top of the building is also a dot. we want to make it super complicated, we could make this problem take 4 days if we wanted to. Okay, so then the angle of depression from the top of the building, 60 meters high. Oop, this is 60 then. Notice me drawing a picture. Strong suggestion on how you should set up your problems. These get tricky and you need a path. The first thing is draw a picture. Second thing is label the picture with all the sides you know and all the angles you know. And the last thing is write a trig equation or a twig equation, whichever. I know one side and I bet you I'm going to know an angle. I do. And just be careful. That's not 60 in there. This is 60 from normal. See, if you were looking straight across, that's 60, so this is 30. And therefore, this one's 60 and this one's 90. It's a 30, 60, 90 triangle. That gives you two options. Uh-oh, sorry, 58. Oh, sorry, not 60. I saw the 60 meters and it messed me up. 58 here. Sorry, that makes it, what is this then? 32. And that makes this 58. And that makes sense because I remember back to geometry that these are alternate interior angles. But anyway, so your triangle, I would probably use the 58 or the 32. Either way, as we noticed last time, you could use sine. If you want to use sine, you're going to use sine of 58 is opposite, which is 60, over hypotenuse, which we don't know. But are we trying to find the hypotenuse? How far is the swing from the foot of the building? We want this distance. So I better use opposite and adjacent. That'd be tangent of 58. Or if you want to use the other angle, you want to use the 32, then you could have used, oh, I guess that would have been opposite over adjacent too. Either way, we're using tangent. Okay, so tangent of 58 will be opposite over adjacent, 60 over x, and then you just have to solve. And you can, of course, could use a calculator. So I gave you too much help on that one. Everybody go to the next one. This one's got the picture. You can trust that we set up the picture right, but you got to at least label the picture. A lamppost leaning away from the sun and at 6 degrees from the vertical. So what would vertical be? Vertical would be this. It's not vertical. It's 6 degrees from vertical, which would imply that this little angle right here would be how much? 6 degrees. 6 degrees from vertical. Well, that's not telling you a ton, but we got a lot more we can label here. The shadow is 12 meters long. Okay, 12 meters for the shadow. And when the sun's angle of elevation is 44 degrees, sun's angle of elevation is 44. So the sun's up here. Angle of elevation is 44. That must imply we're looking from down here up to the sun. Do you get which of these is the angle of elevation then? Because you can't look from the sun and have an angle of elevation down. There's no such thing. So we have to be on the ground having an elevation up. So that has to be that angle right there. Once they told me that angle, they told me a lot. They didn't just answer the question, but at least I've got a lot. I got an angle. I got a right triangle. Oops, 44, not 40. I got a right triangle. I've got a side. That means I can figure out this side. But is that what they wanted? Of course not. Now you have to go and make some more right triangles. I'll let you figure out how to finish it from there. And let's look at your last one together. Notice it starts with this window above the ground. You might be thinking you're here. You're not. You're here because you're doing an angle of elevation. You know you must be looking up from somewhere. So you must be at this building, which is 29.6 above the ground. And this will make a complicated triangle. And that's off the ground, so it'll add the extra little issues to deal with. But basically, draw the picture carefully, and this shouldn't be too bad. All right. The next thing we handle after this does a lot more with those bearings. Remember me discussing bearings with you briefly? You're going to have problems like that for your next assignment. But tomorrow, you're going to be going to one of my colleagues' classes, and we're going to be turning teddy bears inside out. No, actually, we're not. We're going to, no, there's no inside out teddy bears involved. But he is going to be talking about dimensions. And he has a presentation for you on the fourth dimension. You've all heard of three-dimensional. We see things three-dimensionally. We can like see past them, and you know, as opposed to flat things that are two-dimensional. You see a picture that's just something on the wall. It looks flat. It looks two-dimensional. You see you. I can see past you, and I can see kind of like three dimensions. What would it be like to see in four dimensions? And Einstein theorized about it. And anyway, so that's what you're going to do tomorrow. We're going to actually, I'm going to bring you there and then leave you there because I'll have already seen the presentation. And he's going to do that for you, and there will be no homework. So you'll have a nice weekend off of homework. So do a quality job on tonight's because there won't be anything else assigned all the way till Monday. Okay? All right. That's all I got for you for today. Okay.